In today's video, we'll be going through part 11 of our physics review. Part 11 tells us that a rock is dropped from rest from the top of a cliff, and it also tells us that we're going to be using negative 9.8 meters per second squared as acceleration of gravity. When something says it's dropped from rest, we're assuming that it has an initial velocity of 0 meters per second, and we know it's off a cliff. Now, it's asking us to solve for the speed of the rock after 5 seconds. So let's go ahead and write out our information as we did in some of our previous videos. So we have v initial of 0 meters per second. We know that time is going to be 5 seconds. And it's asking us to find the final velocity after these 5 seconds. And if you remember, our first equation in kinematics is Vf equals Vi plus axt. And so we know our initial velocity is 0. Now, we can substitute in our acceleration as being this negative 9.8 meters per second, negative 9.8. We know the time is 5 seconds. Negative 9.8 times 5 plus 0 is just negative 49. And negative 49 meters per second is the final velocity of the rock after a total of 5 seconds. Now let's go ahead and go to part B. Well, part B is asking us to solve for the distance of the rock after 5 seconds. Again, we can use our kinematic equation, and here we have our initial velocity, our final velocity, our time, and our acceleration. So we know our final velocity is negative 49 meters per second after 5 seconds. We know acceleration is negative 9.8 meters per second squared. So now let's go ahead and solve. We're going to be using the equation which is x equals vxot plus 1/2 times acceleration times time squared. Well, we don't know our final position, which is denoted as x. We know our initial velocity to be 0 times time, which is 5, plus 1/2 times our acceleration, which is negative 9.8 times time squared, which is 5 squared. We know 0 times 5 is 0. 1/2 times negative 9.8 is negative 4.9 times 5 squared is 25. Negative 4.9 times 25 is just negative 122.5, and that's going to be our final position, or x. So we have negative 122.5 meters, and that's going to be the distance from the top of the cliff after a total of 5 seconds. And now number 3 tells us that the height of the cliff is 3,000 meters tall. How much time does it take for the rock to reach the ground after being dropped? So here we're going to set up the same thing again. Well, we already know, let's do this in a different color. We already know that the initial velocity is 0 meters per second, and we know this because it said at the beginning that it was dropped from rest. Now, we know the acceleration to be negative 9.8 meters per second squared. We also know that the height of the cliff is equal to 0, and we know that x final is going to be 3,000 meters away. So now we're trying to find the time. But now we can look through our kinematic equations and see which one incorporates all these variables and helps us solve for time. We're going to be using our second kinematic equation, which goes as x equals xo plus vxot plus 1/2 axt squared. And in the last one, we didn't use the initial position or the xo at the beginning because obviously we were starting at an initial position of 0. And I just wanted to include it in this one because our xo is still going to be 0, so we can just eliminate it, what I automatically did in part 2. So we have no xo. Now we know our initial velocity as 0 times time. We don't know t, but we do know that 1/2 axt squared is going to be equal to our final position of 3,000 meters. And that equals 1/2 times our acceleration, which is negative 9.8 times time squared. And we don't know time, so we have time squared. Now we need to multiply this 1/2. So we have negative 4.9 t squared. Divide both sides by negative 4.9. 3,000 divided by negative 4.9. It gives us an approximate total of negative 612.245. And now we're going to take the square root from both sides, because it's equal to t squared. So we take the square root of both sides. And the square root of 612.245 is approximately 24.736. And this is negative. equals t, and obviously t cannot be negative, so we take the magnitude of our answer, and it's going to be 24.736 seconds as our time to reach the ground. Go ahead and write that in our answer right here. An answer of 24.736 as our answer. And remember, that's going to be in seconds. I hope this video helped. If you believe it did, please consider to like and subscribe. I would greatly appreciate it. Thank you so much for watching.